Last episode, we split the code and left the data alone. 2 services, 1 database. That is not microservices, it has a name, and it is worse than the monolith it replaced. Today, we split the data, and 3 things the database was doing for free stop happening. Here is what a shared database actually costs. Identity wants to rename a column. It cannot. The monolith reads that column, so now the change needs both teams and 1 release window. 2 deployables that must ship together are 1 deployable with extra network calls. Every service that can select a table will eventually update it, usually at 3 in the morning. And 1 runaway query takes down everything sharing that server. None of this hurts on day 1. It hurts on the day you try to change something. So here is the pattern. Each service gets its own database, and no other service may touch it. The only way in is that service is a PI. Your schema becomes a private implementation detail you can change on your own schedule. And the bill arrives immediately. Joins across the boundary become network calls, foreign keys become impossible, and transactions across it simply stop existing. 6 details decide whether this works. Private has to mean private, a separate server, not a polite agreement, because if another service can connect, one day it will. The service that owns the data owns its migrations. Foreign keys become plain values the database cannot check. Reads compose instead of joining. Compose in batches, or you have built an N+1 with a network hop in it. And writes lose atomicity, which is a decision you now have to make on purpose. And this is not a style preference. Amazon made it structural in the early 2000s. Teams own their data, and the only way to another team's data is its service interface. That rule is what made 2 pizza teams able to ship without coordinating. Netflix runs storage per service for the blast radius. Segment is the cautionary tale, and they published it. They split into per-service data stores, found the operational cost unbearable for their team size, and consolidated back into a monolith. And Shopify is the honest counterexample, a modular monolith with boundaries enforced inside 1 database. The boundary is the point. A separate database is one way to enforce it, not the only one. So let's do it. In Compose, a second Postgres. Its own port, its own volume, its own credentials. Not a second schema inside the first server, a second server, so that the rule the monolith must not read channels is enforced by there being no route at all, instead of by everybody remembering. And here is the line this whole episode is about. Since episode 2, a video held a channel, a many-to one that Postgres enforced. It is now a string, a handle, an identifier this database has no way to check, pointing at a row it cannot see. That one edit deletes a guarantee the application has relied on for 4 episodes, which means the video list cannot join anymore. It reads its own videos, collects the distinct handles, and asks identity service once for all of them. Once, not once per video. That distinction is the difference between 1 network call and 1 per row, and I am going to prove the number rather than assert it. Let's run it. Same command as episode 4, but watch the output, because it is not starting 1 database anymore. Two containers, 2 ports, 2 healthy databases. Now both services, identity service on 8081, pointed at its own database, and the monolith on 8080 pointed at the other one. Now ask each database what it contains. The monolith has videos and nothing else. The channels table it has owned since episode 2 is gone. And identities has channels. 2 schemas, no overlap. There is no statement either service can write that reaches the other one's data. And the foreign key is not merely unused, it is gone. Ask Postgres what constraints the videos table has left. 1 row, a primary key. There is no F in that list, and there cannot be, because the thing it would point at lives in a database this server has never heard of. So does anything still work? Ask for a video. Title, duration, and views came out of the monolith database. The channel display name came from a different server over HTTP and was assembled into this object in memory. 1 JSON response, 2 databases, and no join anywhere in the system. Now the number I promised to prove. Identity service counts every lookup it serves, so we can measure this instead of arguing about it. Reset the counter and ask for the video list the naive way, 1 lookup per video. 6. Reset it again and ask the batched way. 1. Same 6 videos, same response. The naive version is the N+1 problem, except every +1 is now a network round trip instead of a query. 6 videos is nothing. A page of 50 is 50 calls. Here is the first guarantee we gave up. Delete a channel that 6 videos still point at. With a foreign key, this was impossible. Postgres would have refused. Now it just says delete 1. Ask for that video and it renders with unknown channel where the name should be. Nothing is corrupt and nothing through. The database simply stopped being the thing that knew. And here is the second one, which is the expensive one. Stop identity service and ask for the video list. 503. Not because the monolith is broken, it is fine, but because half of every row lives in a database this process cannot read. A request that needs 2 services is only as available as both. 2 components at 99.9 each give you 99.8. 10 of them give you 99, which is 3.5 days a year. So let's be honest about the trade. We bought independent deployment, a private schema, and a blast radius that stops at 1 service. We paid for it with referential integrity, atomic writes, availability, and a microsecond join that became a millisecond round trip. Every one of those has a fix, and every fix is its own episode, caching, events, sagas, circuit breakers. Naming the bill is what stops this from being a cargo cult. The second database, the deleted foreign key, the batched composition, and the decision record for why it is a separate server are all on the branch. Next episode, identity service knows who a user is. Now it has to prove that to every other service, with no shared session store to look them up in.